So, what is relative formula mass? Now, relative formula mass is a term used to describe the total relative atomic mass of a given formula unit. And what this means is, let's say we had a formula unit. Let's take this for example. This is sodium chloride, which you may know as salt. Hold on, let me change the color on this. I'll use yellow. This is, oh, what the heck? Oh, right. This is sodium chloride. Oops. Yeah. Otherwise known as salt, table salt. And it has the formula NaCl. Now, if we were trying to work out the relative formula mass of this, and before I start working out this, let me just write down the actual definition of relative formula mass, and hopefully this will help you to get a good picture of why I'm doing what I'm doing. It's very, very similar to relative molecular mass, and it's worked out in exactly the same way. Now, relative formula mass is represented by the symbol M. Let me change the color. It's represented by the symbol MR. It's exactly the same symbol as relative molecular mass. Because it's worked out the same way, it's practically the same thing, but slightly different, because it covers a wider scale of things, wider scale of compounds. Now, the definition of relative formula mass is the weighted mean mass of a formula unit. Unit. Let me change the color now. Relative, because I'll explain why. You may already know why. Relative to 1/12 of the mass, or yeah, I'll just use this, mass of an atom of carbon 12. Now, this part, I have explained this in previous videos, but this part right here, 1/12 of the mass of an atom of carbon 12, is often referred to as the atomic mass unit, and it's given the symbol U or dA. U is just like units, and dA is the dA after which means the Dalton. It's a unit, the Dalton, after John Dalton, who created a model, one of the early models of the atom. Now, the reason why I've done this in 3 different colors is because if this was a 3-mark question, this part right here would be the first mark, this part right here would be the second mark, and this part here, the mass of an atom of carbon 12, would be the 3rd mark. Now, the chances of actually getting the question, say in an exam for example, well, let me just keep that up for a second, like this, again, being asked to give the definition for relative formula mass, the chances of being asked to define that is very, very slim, because most of the time with something like relative formula mass, they would usually ask you to figure out the relative formula mass of a given formula unit. Now, let me just get rid of actually it's space here. Now, if we had, let me go back to that example of NaCl. If we had NaCl, use Cl in green because chlorine is usually quite green. But if we had NaCl, let me just draw the charges. And we were asked to find the relative formula mass of this thing here, NaCl. The way we would find it is by adding up the relative atomic masses of these two compounds. I mean, of these two ions. Right now, they'll be ions since it's ionic, but we'd have to work out we'd have to add up the relative atomic masses of these two elements, and we can get that easily from the periodic table. Let me just get up my periodic table and check. According to my periodic table, the relative atomic mass of sodium is 23.0, and the relative atomic mass of chlorine is 35.5. And if you look on the periodic table, let's say take chlorine for example, Cl, where we would usually find the relative atomic mass AR is here, so that would be 35.5, and this would, yeah, 17 would probably be there. Now, so what we do is we add up the two relative atomic masses of these two compounds, and this gives us a total of, let me see, 35.5 plus 23.0, that's 55, no, not 55, yeah, 50, 55, 58, 58.5, 58.5. That would give us a relative formula mass of 58.5, and the units we use for this is grams per mole. The units of relative atomic mass are grams per mole. The units of relative formula mass are grams per mole. The units of relative molecular mass are also grams per mole. So we write grams as in G per mole, MOL minus 1. And I'll be doing some videos on the mole, on why this unit is the way it is. And yeah, this would be the relative formula mass of sodium chloride. Now, the difference between relative formula mass and relative molecular mass is that with relative molecular mass, it includes compounds with a giant ionic structure, such as sodium chloride. This has a giant ionic structure. As you can see, this here, I've drawn like lines around here at the edges, and this is sort of like a sort of crystalline structure, and this would basically extend out this way, this way, this way, this way. It'd extend out in all directions, so it would be a giant structure. This is a giant covalent structure, because this would extend out in many different directions. I've just drawn a simple part of it for simplicity, and this is silicon dioxide. We call it silicon dioxide because it has the formula SiO2 dioxide. Now, silicon dioxide is a fundamental component in quartz, and you may know quartz as used in jewelry and things like that. It's really shiny, so almost like glass, and it's used for types of glass. But quartz is one of the most abundant minerals in the Earth's crust. So it has loads of different uses. But yeah, this would extend out in all these different directions. So it has a giant covalent structure. Covalent. That's an A here. Covalent structure. And so because of this would be given a formula, and it's not a simple molecule. It's a very like giant molecule with giant a compound with a giant structure. And because of this isn't included in the term relative molecular mass, but it is included in the term relative formula mass. And in my video about relative molecular mass, I gave an example of one of the, like, a simple hydrocarbon. I'm not sure which one I gave, but it might have been ethane. Yeah, ethane. But regardless of what that was, ethane is a simple hydrocarbon. It has the formula C2H6, and it would look something like that, with all those sticks leading to hydrogens. And this is a simple molecule, so this would be included in relative molecular mass. But relative formula mass would not. I mean, relative formula mass would include this as well as all of these other things. So relative formula mass can be used for any formula unit. So what I would suggest is that, unless the question specifically asks for relative molecular mass, you can use relative formula mass to refer to any molecule. Now, let me just go to. I'm finding out relative formula mass, finding out relative molecular mass. I'll do videos explaining how you can work these out for more examples. I gave you one there. I'll make a video where you can work it out for more examples. And in summary, because I'll just write up the definition of relative formula mass, which was, and I'll do the three colors as well, which was the weighted mean mass. And you may notice a similarity between this and relative atomic mass, because this uses relative atomic mass to be calculated. So this is why it includes the term weighted mean mass of a formula unit. Of a formula unit. Different color here. Relative to 1/12 of the mass. Change color here. Of an atom of carbon 12. Carbon 12 being a specific isotope of carbon, which can also be represented as C with a little 12 superscript up here. It just means the same thing. And as I said before, these three colors would represent the 3 marks, or the 3 points you would want to include if you are trying to explain the definition of relative formula mass. And that's the end of this video. Bye.